Well, good evening, everybody. Mike Flink here with Autel. I'm going to give it just a couple of more minutes for those late getting back from the shop or that might be just a little bit late here joining. So bear with us here for just a couple of more minutes and we'll get things started. All right. Well, good evening, everybody. I'm Mike Flink with Autel Diagnostics. I'm our Director of Sales and Training here in the North American office. Before we begin this evening's broadcast and webinar, I've got some tips and housekeeping things to go over for everybody. On your menu bar, usually it'll be on the right side of your screen, you'll see a few tabs. Main one of these to be concerned with is the questions tab or chat tab for you. Because there's going to be several of you here, several hundred of you here this evening, not really possible for us to talk and interact directly with everyone. So keep things moving. Post your questions in that chat box. I'll try to answer some of them since I'm off site from where John and Philip are on the doing this webinar tonight as we go along, and we'll leave time at the end to answer all of them. We'll also try and send out a bulk answer sheet. So any of the questions that we don't get to during the broadcast, we'll make sure that you all get after the fact so we can go over any of those. To keep things moving along, in full disclosure, portions of tonight's piece were pre-recorded because we're going to be using multiple vehicles. We didn't want to tie you up while we were connecting and disconnecting. So with that, I'm going to throw it on down to Philip Austin from NGK that'll head us off tonight, and him and John down in the room where we're broadcasting from. Have a good broadcast, guys.
Okay, welcome to another webinar series in which we are looking at just Europeans. We have a BMW and also an Audi. And we're going to go through using the Autel Maxi Ultra and looking at the functionality of the scan tool, the scope option, and also component testing option on European vehicles. So let's put this to the test. And also we're going to be checking components that's related to NGK, ignition related components, coils. We're going to be looking at the NTK sensor related components, cam crank sensors, things of that nature, looking at what we could see in the data page and also analyzing certain aspects of the engine management system. So I am ready to rock and roll. I have two Autel representatives here with me, and we're going to look at both of these vehicles together and see what we could check out.
Okay, this particular Audi that we have supports something as we hooked up our scan tool that's called DOIP. DOIP is a relatively new term to a lot of technicians within the industry. What does DOIP stand for? Why is it important? DOIP stands for Diagnostics Over the Internet Protocol. Autel is proud to say that we support that protocol. And what does DOIP allow us to do? It allows us to take a piece of diagnostic equipment made for servicing an automobile in the repair facility and being able to hook that up to the internet and perform remote diagnostics. Now, all of our Autel scan tools, the topper end of our spectrum here, do support remote diagnostics, which is something that we can go ahead and certify that somebody's an expert in a certain area, whether it be reprogramming or some form of diagnostics, whatever the case happens to be. And we all need help from time to time in our service space. Maybe we don't have the equipment, maybe we don't have the knowledge or the experience on a certain type of car. And if I go ahead and subscribe to remote diagnostics, I can go ahead and turn that feature on my scan tool, and it will pull up a list of people that are qualified for the area that I need help with. And then I can select. There is a fee, obviously. Those people aren't going to work for free. They're people like you and I. We all have our specialties within the industry. We just, at Autel, vet that they are a legitimate expert, and then we can rely on their experience or maybe their equipment if it's relating to programming or whatever the case happens to be. So with the DOIP protocol that a lot of the European cars are going to, we need to be able to support that with our diagnostic equipment so that situations like what we just described can actually occur, whether it be remote diagnostics, remote programming, whatever the case happens to be. Another thing to keep in mind with the DOIP protocol is it will give me a list of, if I'm the expert that's actually interfacing this, of every trouble code that was ever set. So this is beneficial as well. It's kind of like dealership networks had this ability for a long time, not so much through the actual vehicle, but if a car came into a dealership, it was programmed into their little computer. So even if I took my car to, let's say, a Chevy dealership in Ohio, and then I moved out west to California, because they were all within that General Motors network, that new repair tech at that dealership could pull up the repair history and the complaint histories that I had on my vehicle. We have that ability here with this new type of protocol. So when I first hook the scan tool up, it asks me, it tells me that the vehicle supports it, first of all, and it says I can use the DOIP protocol for testing. Do I want to use the DOIP protocol for testing? I'm going to say no in this instance. I don't have to say yes. I'm going to say no. And we're going to keep it internal here as to us doing types of testing on this vehicle. So we'll let it establish communication. I'm pretty sure I left the key in the on position here. And again, all the screens look very similar. We start off with the topology screen. We can also select the list to see all the different modules, see if it supports ADAS, stuff along those lines. And then I have all of my little buttons on the left. I can do a fault scan. We've done this on several other cars throughout our training webinars here with NGK. So just to save a little bit of time, we'll bypass that. We have our hot functions. We referenced those in 2 of our previous webinars as well. And we can go right through the list here, or we can select specific types of information that maybe Phil wants to share with us here.
Yeah, great. Yeah, thanks, John. So if we hit full scan here and just let it go through its thing, and we could just simply type in the customer information, and we'll put a substitute license plate in there. And
anything with an asterisk has to be filled out. So once I did that, now it's doing its thing. Notice that it's going ahead and talking to each one of the modules on the network. You can see how many modules this particular Audi, now that is more top of the line type of vehicle, but there are many different modules talking to each other across the various networks that this car supports here. Anyone that actually has a trouble code will actually be highlighted with the little orange, and it'll give you a little number in a circle, represents how many different types of codes there happen to be.
And what's great about this too, look at the color coded of the modules that has not been scanned yet, and which are in blue, and the modules that have been scanned in the past are in green, and if there's a full, it'll pop up in the orange. And if we have no response, another great aspect of the Autel scan tool, that if we're not getting any response with that particular module, it's going to show that up in gray.
Also, the color coding of the wiring on the topology screen can aid in your diagnostics as well. Not just necessarily on European cars, but any of the vehicles that we've been talking about. So each one of these different color codes up there represents a different communication line of data. So if we happen to notice that all the modules that were connected on the red line here had no communication, well, that's going to give us a diagnostic pathway, so to speak, right? We probably don't have a half a dozen bad modules that are causing the problem. It's probably more of a circuit type of problem that we'd want to go ahead and address our attention to. I don't want to attach any photos to the pre-scan, so we're just going to say no. And at this point, we do have the Intelligent Diagnostics button, so we'll go ahead and click that.
Yes.
Now remember, we did have a couple codes that pulled up.
Right.
We got a couple technical service bulletins that may or may not apply.
Yeah, and what's cool, if you see on the very top here where it says all systems, so if I click on all systems and I say, hey, listen, I just want to see what's going on related to the engine management system, because as we can see, you have the engine control module here and all the codes related to that. Then you have the ABS system, and then the brake system, tire pressure warning. So depending on what direction you want to address what the customer is coming for, and this is all about meeting the customer needs while performing the diagnostics. So if the customer just came due to the check engine light or some sort of drivability concern, then we'll walk down that path, right? So just for giggles here, let's just stick with this particular ECM code, and the Intelligent Diagnostics here show you the technical service bulletin that may be related, like this P0441. So let's click on that, and you can see here it outlines the technical service bulletin just to allow you to go through your diagnostic process. And what's the diagnostic process? First, we verify the customer concern, right? Then we are able to walk through if there's any type of history that we could learn, like John just mentioned. If we wanted to take the route where we're going to go through the part of the Audi diagnostics where we could look at the entire history of what was happening with this vehicle, any codes from the past, fine, but having a conversation with the customer, repair history, understanding what may have been done within the last 30 days or so, and then continuing to what we're doing, full system scan. Look at the DTCs. We see that we have a DTC, and the technical service bulletin is the next step of the diagnostic process. So as we go through the diagnostic process, it's nice to work with scan tools that will show us intelligent diagnostics to bring them back in, instead of us stopping and going, okay, let me go look in my information database. on a different system. So this is really, really helpful in streamlining our diagnostic process. So with this here, we could take this into consideration that the condition is that the customer has problems fueling the tank, right? So right now, we go through the technical background through it, and then look through the possible solution and carry on from that point. So this is really, really cool for us to look into different type of component testing. Like if we wanted to go into this right now and do the canister purge testing, then automatically it sets us up with a known good, and we'll be able to look through that and say, okay, I want to look at the data and see what we're finding with that. So what's great about this, it walks you right through. We don't have time to actually go through all of that, but it's good enough for us to show you the functionality, where to go, and what these options are. So let's back out here for a sec, and yes, we want to exit and continue on. Now, when you look at some other relevant cases, you could look at that information as well to just get an understanding of similar systems so that you could understand how to walk about troubleshooting that. But I want to dive into, with John, all the other lit features here where we could go into the hot functions of it and see what we could do there, from resetting the oil light all the way to the battery management system, right? All these options are available to us. So if we go back and just rescan again. Okay, I went back a little bit too far, but it's okay. Say no.
And while we're waiting for the scan tool to catch up, you know, something as simple as resetting the oil change light. On other types of vehicles, a lot of the domestics, it has gotten more difficult over the years, but I would have to say that some of the hardest ones to reset the oil change service light, something as simple as that, not even a real high profitable job for a typical auto repair shop, are the European vehicles. In fact, there was a time in my career where you had to buy special service tools for the European vehicles just to reset that oil change light. It's nice that we have that feature built in, especially on European cars.
Yeah. So going into the control unit, thanks for that, John. If we go into the engine control module, and then we want to pick what option that we want to look into. Let's go and look into what we could activate, because it's all about diagnostics and using this bidirectional diagnostic system to aid in streamlining your diagnostics. So if I want to check the coolant fans, they're not operational, I could actually run this particular test right now to activate everything within that circuit, the relays, the computer commanding it on, and do the appropriate testing with our DVOM in graphing mode to watch the current or even watch the voltage. So this has a split screen which you could look at both. You have an option as well too, if I was to back out here and I go back in, it gives me an option to look at the scan tool data while I put that command of all the fans. So this is really, and this is where you click on that to look at the live data, and you click everything that you want to be able to visually see related to the coolant fans to look at that live data. So this is really great for us to use within our diagnostics when it comes to this. Now, of course, when we look at the live data as a whole to list all the data PIDs, it gives us some options here. And like we showed you in the other webinars too, we want to be able to select what we really are interested in seeing instead of scrolling through everything. So this particular one, let's start it up and then we can just look at some live data at this point. So in the meantime, see the laundry list of all the data PIDs that are here. In today's vehicles, we have to start selecting what we need to see in order to come up with our diagnosis here. As you scroll through all of these, you can see how long this list could get here. So if I want to look at the engine speed, I want to look at my long-term, short-term adaptation. I want to look at my oxygen sensors. And this is the information that we could just, I'm just selecting a few here so that we could just be able to graph out and show you, so you just streamline what you want to look at. And as always, like we showed you with others, we don't want to get tripped up over all the data PIDs that the manufacturer specific has on this Audi. Unless you're like an Audi tech and you used to work on these a lot of this will look familiar. But if you're not, we always have the option of switching over to our generic OBD2 mode of that. All right, so we're gonna auto scan this because we don't know exactly what the protocols are to pick from. We know a few, but we'll let the scan tool do the work for us. All right, we're gonna hit OK. And now at this point, now I wanna look at live data. It's calculating the number of pins in which you're gonna be reading off of. We're gonna, hopefully it's not gonna be as long of a list of the data PIDs under manufacturer specific, and we see what lines of data that we could easily look at. So if I really am interested in like RPM, more so fuel trim related, I'm thinking about that I want to use as an exercise for this, and I want to be able to look at my, here we go, short-term fuel trim, bank 1, long-term fuel trim, bank 1.
It's only going to be a bank 1.
Yep, it's only going to be bank 1. I'm just looking for my lambda reading. We have the milliamps for the oxygen sensor. All right, okay, bingo. So you notice it didn't just pop up at me and first showed the equivalency ratio. Those terms are interchangeable because we're just looking at our lambda reading here. All right, it's gonna click for me, great. All right, and the fuel air command equivalency ratio, I'm gonna hit that. All right, and let's just kind of look at that, what we selected. So now this car does not have any known issues, no check engine lights related to what we've seen, but from a fuel trim perspective, we looked at a lot of manufacturer-specific data PIDs that could be confusing to a person or tech that is not used to looking at or looking through the lenses of Audi Diagnostics. We could always fall back on OBD2 global information. We have the RPM at idle. We have a short-term fuel trim at about 9%. Bank 1, this is an inline four-cylinder, right? Now the long-term fuel trim, so 0 here. Now, let's keep in mind, just because it's an inline doesn't automatically mean that it will only have one bank. We're going to look at a BMW later on, and some BMW applications, you will have bank 1 for the first 3 cylinders and then bank 2 for the next 3. But on this Audi, one bank. What I want to focus on here is the equivalency ratio and lambda. Look at that, it's right about 1. We want that to be right about lambda 1. Because anything higher than lambda 1, let's say lambda 1.38 or something like that, that means, hey, you know, I need to look for a lean condition. What's going on with that? If my lambda reading is below 1, then I'm looking for like a rich condition. Now, if it has a rich condition, we know the computer is going to start compensating for a rich condition that it's trying to control, meaning we're subtracting fuel. right? So we can still apply the basic knowledge that we learned about OBD2 engine management systems and their strategies for fuel trim by understanding Lambda, especially with these Euros. We're going to cover this on the Audi, and we're going to cover this on the BMW, and we'll look at it later. So don't get tripped up over the air-fuel ratio sensor readings that the manufacturer-specific data PIDs may have on this application. Fall back on Lambda. What's my Lambda doing at idle? What should it be, right? So Lambda, just in terms for those that may not be familiar with that terminology, the days of us looking at stoichiometrics, the 14.7 parts of air to 1 part of fuel, we're that perfect condition, right? So anything outside of that, okay, we have to look at that 14.7 stoichiometric number in terms of Lambda is 1. So anything above Lambda 1, we're searching for a lean condition. Anything below Lambda 1, we're searching for a rich condition. So us just looking for Lambda 1 or what Lambda is, we know what direction to go in. Right now, we're hovering around Lambda 1. Another data PID that I picked out here, it has the fuel air commanded equivalency ratio. So it's commanded to say, listen, I want to be at Lambda 1.002. And we can watch the actual reading and see whether it's there. So it's a great comparison. So even if you didn't know, based on what I just said, the computer's already targeting to say, listen, I want Lambda to be here. And then you look at the actual reading as it's running to see whether it's staying within that. So I hope you were able to get a good takeaway from that aspect. And we're going to continue on the next step here.
Okay, now we have a 2011 BMW product, and again, we want to kind of really emphasize this. We'll go ahead and do our pre-scan on the vehicle. We'll go ahead and select fault scan. Again, anything with the red asterisk we have to fill out, so we're just going to make up a name for the license plate here, say OK. And it's going ahead and scanning all the modules. Now the reason why a pre and post scan is so kind of important, obviously for insurance purposes, if you're in the collision industry, it's mandatory. But in the auto repair industry, the service part of it, it's not really mandatory as of yet, but it's a good practice to get into because number one, it forces us to communicate with all the modules. A lot of times, there may be some trouble codes in a module that maybe are being influenced by other codes in other modules. So a prime example of this is we'll go ahead and stray away. We'll keep it import, but we'll stray away from the European car line, make it something a little bit more popular that a lot of people have seen. On a Toyota product, if the check engine light comes on, your ABS light comes on, your traction control light comes on. And if you go through and do this type of testing, you'll notice that when you pull those codes out, you don't really have all those problems. You have one problem, whatever that code is in the ECM, and when you fix that, the other codes are going to be repaired as well. Also, it's good safe practice because I can print these reports out, give them to the customer and say, when you brought me your vehicle, these are the codes that you had. When it left, the codes that I was hired to go ahead and address and repair are now out of your vehicle. Maybe they didn't allow me to repair all the different codes, so obviously those codes would still be present. So I don't want to add any photos. Now I actually have a legitimate pre-scan stored. I also have some intelligent diagnostics, and I do have codes stored, and it looks like about 7 different modules on this particular vehicle. So I'm going to hit the intelligent diagnostic button. I have no TSBs available for me, but I'm going to go to the diagnostic trouble code analysis section, and I have one up on top here is a communication error with the GPS system on this vehicle. And the other one is a media software reset, right? So if I were to talk about the communication issue, click on that, I can pull up and I can get that specific information that maybe I'm not quite familiar with because it's a European car. So for instance, the condition for setting the code, the supply voltage to that module was from 9 volts to 16 volts. The terminal R was on. Check for the fault during the startup and during the silico test routine, currently every 30 seconds. And it also tells me some possible solutions of programming a specific communication box. If programming was not successful, it tells me to go ahead and replace that box, right? So for that particular code, if I've never had any experience with it, I know what to look for when I start doing my pinpoint diagnostic testing now. I know the voltages I should be looking for. I know the conditions that it has to be in for me to properly test and diagnose that. And then I also know what my course of action would be. So let's say all my supply voltages tested out good. I could try to do the reprogramming on that particular module. If that did not happen to fix that particular code, then it leaves me one other choice. I'd have to go ahead and replace it. Now remember, if you don't have the ability to program a European car or a domestic or an Asian car, but since we're talking about European cars, you may not have all the European fancy software to go ahead and do it. Or maybe you have a J2534 box, but you're just too shy or timid to do it on a car such as a BMW. Little personal story, my one-man auto repair shop was right next door to a very affluent body shop. And I got a ton of work from that body shop all the time. They called me up one day and they asked me if I could reprogram a BMW for them. I said, sure, go ahead and bring it over. I didn't have the OEM scan tools to do it, but I did have J2534. And when I went down that process of programming that BMW, the little status bar that told me a time frame told me it was going to take about 3 hours and 15 minutes. And I said to myself, is it really going to take that long? Because we've seen that before where it says it's going to take a long period of time, then all of a sudden it just speeds up and doesn't take anywhere near that time frame. Literally took 3 hours and 15 minutes. It programmed that particular BMW, forced me to I only wanted to program one module. It forced me to go through every single module and install all the updates. So we're a total of 62 modules on that BMW, which is why it took so long. Anybody that's done reprogramming in the past knows there's some safety concerns involved. 99.999% of the time, everything goes off without a hitch. But if for some reason the tool becomes disconnected from the OBD2 connector, or you lose internet connection, or anything crazy like that happens, you may have just bricked a module. And in that case with BMW, I might have bricked several modules on that car. So this would be a prime one that maybe if I felt timid at all, if I got to this section of having to reprogram, to choose the remote expert option and find a remote expert that would take on the job, somebody that has the experience to go ahead and do that reprogramming for me. I'm going to escape out of here. I'm going to hit the escape button one more time, and I'm going to scroll back up here, and we have what's called Repair Assist as well. So I'm going to click on that button, and it gives me a list of the different types of codes that could be stored on the vehicle. Gives me a short little definition of whichever one here. But if I were to select on this one here, I'm going to establish some communication. Let the screen go ahead and update here for us. I'm going to select next step, and got it. And here I pull up for the brake fluid level switch, I pull up specific information, repair type of information, hence the reason why we call it Repair Assist, on the actual brake module. So I may not have information system that can pull the information up, or since we're talking European, the wiring diagrams that are common on European vehicles are what's called DIN network type of diagrams. It's very foreign to a typical tech if they have not used that type of wiring diagram before. The nice thing about the Autel scan tool is once I know a certain area I want to concentrate my diagnostics on, I can go in through the intelligent diagnostics section and I can pull up a more conventional looking wiring diagram that maybe I'm more familiar with reading, which is pretty much what all the domestic and Asians have used for decades. So I wanted to pull that section of the scan tool out for us as well. And at this point, I'm going to turn things over to Phil, who's going to take you to the next step with using our fabulous scan tool here, diagnostic equipment, and using it in some real-world scenarios.
The next thing we're going to look into here, this being the N52 engine, straight 6, and a couple of points I'm going to go over here from the scan tool point of view. So we have all the vehicle information in. I'm going to continue on and allow it to establish communications. A couple of things I'm just going to highlight on the data stream, but more so on what the Autel Ultra can do when as far as functional tests. Okay, if we're with this engine, you get misfire codes, and sometimes we have to kind of rule some things out. So I'm going to walk you through some steps here, and as we're continuing to scan and get the information in, we'll walk through that. Meantime, I'll swing to this side so I got more of a good angle. So as I talk about some things here, we could view this and also get an idea where it's at that I'm talking about here on the engine. So on this, the key engine management components here, this is a VVT system with a Vanos cam phaser. The setup, we have an exhaust and an intake, a VVT solenoid that is right below here. And I'm not going to go through the whole full scan. We went through that before. I'm going to go right into control unit and pick the control unit that I want to access and look at the different functional, or some manufacturers may call this a active test. All right, so I'm picking the control unit for the engine. Now I have an option of trouble codes, live data, or active test. So at this point, the engine is running well. However, we want to get an idea of the fuel injectors and how they're contributing to the engine. So if we had an intermittent P0300, then what I would want to do is verify what's going on with my injectors. Okay, so I'm going to go to active test and I'm going to look for fuel injectors. Now you have two different options. You have a clock fuel injector test that you could do. I'm looking for fuel injector off for every cylinder. So when I hit fuel injector off, it's going to ask me to activate or deactivate. I'm going to activate it, and then I'm going to be looking for a noticeable drop in the RPM. Okay, so let's go through that test together. Activate injector number 1. Automatically I see a drop in RPM and it begins to miss. Obviously it's a lean type miss because we killed the injector for that cylinder. So I'm happy with that. Now the next thing, and I'm recording this by the way, and I'm going to go back and review it too. I'm going to back out and I'm going to go to fuel injector number 2. I'm going to activate it. I see a noticeable RPM change, drop. I'm happy with that. I back out. I go to fuel injector number 3. I'm going to activate it. I see a noticeable change or drop in RPM because I'm creating that lean misfire. I'm seeing how is the engine being affected when we pull an injector off from contributing. Deactivate, allow it to stabilize, and I'll continue the process. I'm going to go to injector number 4. Activate. I notice a considerable difference as well. Deactivate. Let it stabilize. Now, injector number 5. Activate. I notice a similar difference as well. Deactivate. And last one, injector number 6. Activate. I'm noticing the difference as well. So just that test alone, I could see how when I kill a contribution from the fuel injector, this is the GDI system, of each cylinder, there's a change, a pretty similar change to each one. So when we are having a problem, let's say this is misfiring, you could actually see whether the fuel injector is contributing to the misfire or not. So it's nice to look at a known good vehicle and do that test so you can see the difference. Okay, so if this was misfiring already and I kill injector number 2 and I don't see any change, then I know, okay, I didn't see any change, so injector number 2 is where I'm going to investigate further. Great. So looking at that information is very helpful within our diagnostic process. Another thing too that I want to review is when I go into back into my control unit, I hit live data, and also I'm going to go into operational smoothness values. This is a way in which you could actually look at how each cylinder is performing. Now, obviously no one knows the exact figures in which it should be. We're looking for similarities for each cylinder. And if any of them are out of the range, that's what I'm looking for. So here we go. We have cylinder 1, 2, 3, 4, 5, and 6 noted here. And you could see they're all within range. And I'm happy with that. If I was getting a misfire, I should see some sort of change in one of those cylinders in regard to operation smoothness value. So coming out of this, and I already have this already pre-selected. So at this time, what I'm going to do is just back out of this and go back in so that we could actually see a little bit more information. You see I have operational smoothness value. It's only going to show you the data pits related to that. So let's say that I want to go into the variable camshaft timing here. Then it would show me only the values that's related to that and be able to make the comparisons between the camshaft timing adaptation value and the variable cam timing position for exhaust and for the intake. And we're looking for whatever that adaptation number is, should be pretty close to the adaptation of that. So let me back out and go into oxygen sensor control, in which what I like with the Euros, it's just going to show me everything related to that. We don't want to get into that heavy listing where we got to select only the ones that we're concerned about. This kind of helps us, keeps us in the ballpark, and where it shows additive and multiplicative. One thing I want to clarify on that, for those of you that would like further explanation when you see those data pits, this applies to Euros that will show those type of data pits. Additive, keep in mind, it's looking at idle, okay? And anything outside of idle, in short, making the fuel trims, any type of adaptation outside of idle will be multiplicative, under load, and it's able to give you that calculation. So it's looking at it from 2 sets of lenses. So additive, just look at it at idle, right? Okay, and multiplicative, look at it when it's under load, off idle, okay? So when we look at those numbers, it gives us an indication. But again, if it becomes confusing to you, always default back to global OBD2 on these applications, in which it would put it within terms of which we all learned it for all vehicles, in which we're looking at short-term, long-term fuel trim, and things of that nature. But I just wanted to show the comparison of how in certain Euros like this BMW for additive and also multiplicative adaptation data pits. So this is a nice setup here that the Autel scan tool has for us to be investigating different options and different live data PIDs that we could see. So I hope that information was very helpful for you. Another piece of information I'm going to share, since we touched on the VVT system, especially with the exhaust and the intake variable valve solenoid. What's very important, especially when you're changing the oil in these engines, the concentration is on the oil filter, but whenever you get an oil filter with this kit, they always give you a little round O-ring that's supposed to go at the very end tip of the ridge that fits into the filter. That's very, very important for the VVT systems, because, especially explaining your C-Techs, don't look at that and say, oh, I don't need to replace it. It definitely needs to be replaced, because you know what? It plays a role in holding the oil through its channels and not bleeding back, which could cause issues with the VVT system as well. And it could run you in circles thinking that you have a problem within your VVT solenoids, but the problem is it's not holding the pressure because that round O-ring has never been replaced and it's worn or it's missing. And it bleeds off when it's not supposed to. It causes all sorts of VVT related concerns with that. So keep that in mind. And whenever we're changing these VVT solenoids as well, I'd rather change them together as a pair instead of just changing the exhaust and leaving the intake one there as well. Also make note of the connectors for them. They are interchangeable. I've actually seen where guys have replaced the VVT solenoids. The connectors are interchangeable. The car's running like crap. They go into deep diagnostics doing an in-cylinder transducer test and noticing that, hey, we may have a mechanical issue going on with this engine, but not really. It's because the VVT connectors were interchangeable, and it's actually inducing that type of misalignment or missynchronization of the VVT system. And we need to search and understand the why first and the root cause before we dive in and make assumptions about that. So for you guys to do in-cylinder pressure testing and learning how certain patterns are supposed to look, always remember, understand how the system is supposed to work and how it's designed, and don't leave out doing that visual inspection and saying, okay, is my VVT solenoids wiring diagram matching where it's connected to for exhaust or inlet? Key tip. So that's pretty much it on this, folks, and understanding. One last piece is, when you're trying to troubleshoot the fuel trims and understand, and if you really didn't capture additive and multiplicative type adaptations of this, always go into generic OBD2. It would show you the short-term and the long-term fuel trims in the generic understanding of it, but it will also share with you lambda readings. And you always want to make sure, like we mentioned before when we were working on the other Euro, the Audi, is that we're looking for a lambda reading of 1. Anything over 1, you're searching for a lean type condition that the computer is compensating for, okay? Meaning it's going to try to enrich in it because it's sensing a lean condition. Now, if it's under lambda 1, then we're searching for a rich condition where the computer is trying to subtract fuel. So knowing where to go using not just the Autel scan tool, but any scan tool you're going to be using, but since we're concentrating on the Autel Maxi scan tool, know how to navigate it to meet your needs, okay? And go into generic OBD2 and understanding the basics of that when you're looking at fuel trim and other aspects of the emission systems on these Europeans, it helps simplifies things so that you could go about trying to troubleshoot. Again, if you have an intermittent drivability problem too, check engine light is not always on, and you want to have an understanding of how is the computer looking at this. We still have that generic OBD2 platform in which we have mode 6, where we go into any one of the categories that may be related to the system malfunctioning. You look at the min and the max and the actual values. So we don't want to get tied up into all the data PIDs that we're looking in the live data stream on the manufacturer specific or even global OBD2. But if we can't capture it, let's go back and look at the mode 6 information to see whether that can help us and be able to proceed with the diagnosis from there. Well, that's pretty much it in covering that, and we're going to take some questions now at this time.
All right. Well, thanks, Phil and John, for your work there. Had a couple of good questions during it, which I hopefully everybody saw. We did the answers, some dealing around lambda and why, of course, there were the fluctuations in those readings. And that is typical. The vehicle's working. Its ECU wants one is perfect, but it is compensating for itself as it goes. Minor fluctuations like what we saw there are very common in a vehicle dealing with atmospheric air, how the fuel's, atomizing through everything. But as long as you don't get a big variance by a percentage point or two or more, you're right in line with it. Another one was asking about the ability when you're doing some of those cylinder balance tests to be able to record those RPMs or look at it. And yes, a lot of the tests will actually ask you what data you want to view. And somebody else chimed in from our team about the fact that you do have that split screen option with the Ultra. That's exclusive to the Ultra. Some folks were asking of the tool, and it was an Ultra we were using. Our 909 and 919 tools, MS 909, 919, have all the same features that we saw tonight, other than that split screen feature somebody mentioned on that one question. The only other difference on that 909, it doesn't include the scope, but we didn't really get into lab scope as much tonight as we have on other ones. James just asked it, and that was the end of our broadcast part of this. We had about 45 minutes of content we planned for so that we'd have time for questions here at the end, James. But I'm not seeing any more than those couple I just answered. If there are any last few ones before we cut it off for the evening, let you guys all get to your home or to your activities at home or your home evenings, we'll give it just a couple more minutes for any other questions that there might be.
One thing, this is John Foro, by the way. One thing I kind of wanted to just call out about our scan tools is Philip was showing at the very beginning of the webinar our hot functions feature, and that is a real time saver for working technicians, because I like to call it a service menu, but it's hot functions on your scan tool. And basically that, if you wanted to do something like a brake job and retract the brake calipers or reset the oil change light or whatever it happens to be, you rotated the person's tires. The problem is even though the scan tools are capable of doing those tasks, a lot of times you'd have to go searching through all the different modules on the network. So what Autel has done is we've put them all on a very user-friendly, easy to get to area of our scan tools, so that this way it saves you valuable diagnostic time if you're just looking for, say, retracting the rear brake calipers so you can do a brake job on the vehicle. You don't have to go wondering, hey, is this going to be found in the ABS module? Is it going to be found, at some other module on the network here? So I just wanted to kind of clarify that a little bit. And if you haven't been using that menu feature, definitely check it out the next time you're using one of our tools.
Yeah, that's a good point, John. Also, too, everyone could kind of see on the screen the dates for the upcoming next ones. Feel free to make use of those QR codes as well for you to get an early registration, and also provide some feedback too, or some of the things that we can kind of add or adjust in order to meet your needs. So we're pretty excited to make this adaptable and cover the various topics too. All right, well, it looks like we are pretty wrapped up here. I thank everyone for attending. I'm not seeing any more questions kind of rolling through, but any questions that we did not answer or was able to answer, we're going to download this and send you an email with the answer too. We don't want to leave you out. So thank you all, and we appreciate the feedback and your time.
We did have one last question there, Phil.
Oh, okay.
What we do with Autel is to model after those OE. So for your question, Moses, yeah, you should be able to do it all with the Autel and not have to have the VCDS system for diagnostics. The only qualifier, I noticed you talk about having the 906TS, our smaller platform. 98% of what we're showing you'll be there. John got into that DOIP on later model that's coming out, Diagnostic over Internet's protocol. That requires one of our top tools that have the pass-through type device, either the VCMI or the VCI. That's a J2534. So you would need to be in one of the top tools rather than the 906 for some of that DOIP and higher level stuff. You get into the programming and advanced coding, but the majority of it you could even do with that 906TS as well, Moses.
Great. Thanks for answering that, Mike. That was a pretty good question too. All right, is there any more before we close out? Looks like that is it. Thank you so much, ladies and gentlemen. I hope everyone have a good night, and thank you again for attending. We appreciate this, and we look forward to seeing you in August, October, and December. Have a good night.